Hi everyone, it's Miss Langrage here. I put some makeup on and brushed my hair today because I had some comments from some of my students saying that I should not look like such a mess on my videos, so I am trying. I want to thank all my students who've been doing math at home and sending me their math online and showing me the work they've been doing. So one of my students was working on the post-March break work that I posted on Google Classroom for my grade 10 class. You can see that package of questions. If you go to Google Classroom, I moved it to the top, so it's one of the top things in the Google Classroom feed. And she was asking about one of the last questions from that package about a diver diving off a diving board into a pool, and it was a graph of a quadratic. So I have drawn the question on my chart paper and I will show it to you now. Okay, so this was the question. I believe it was C3, the last question in the booklet, and it's about a diver diving off a diving board. So I've done my best. I made a picture of the diving board, and right there you'll see the diver, and the diver is going to jump up and then fall down into the pool, and the graph will be a quadratic. There were some questions. I'm going to pull my computer over so I can see the questions. The first question was, how long is the diver in the air? How long? Oh, that's not a, you know what? My graph that's in the booklet and my graph on the table is not great because it says how long is the diver in the air, suggesting this is a graph about time. Well, there is no time on my graph, so I'm going to change the graph a little bit to change this from distance to time in the air in seconds. Okay, so we're going to change the bottom axes, the horizontal axis, from being distance from the diving board to time in the air. So we can see that at the beginning, this right here is time 0. And at time 0, the diver is up high because the diver is on top of the diving board at the beginning. The diver jumps, goes up a bit, and then comes down and gets into the pool, into the water after 8 seconds. So that means the diver is in the air for 8 seconds. Okay, that's the first question, question A. Question number B, or letter B. When is the diver at a height of 12 feet? Height of 12 feet. So I look for where it says height on my graph. Here it says height. Here it says 12. My height is 12. So I'm going to make a horizontal line. And I'm going to see that, oh, there is where it meets the diver's path. And I'm going to go down and look for at what time is the diver at a height of 12 feet. I'm not sure if I drew my graph exactly like the one in the picture, but from what I can see, if this is 6, this is 8, this is 7, so maybe this is 6.6 seconds. At 6.6 seconds, the diver is at a height of 12 feet. The second question says, when is the diver at a height of 18 feet? So where is 18 feet on my graph? Here is 16, here is 20. In the middle of 16 and 20 is 18. So what I want to do is I want to draw a horizontal line, and I see that my diver touches 18 on the way up and then touches 18 on the way down. So the diver is at a height of 18 actually 2 times. Now you need to remember that there is symmetry. So before I finish answering this question, let's look for where the vertex is. The vertex is the highest point, and the vertex is right here. And if I go down, I see that my vertex is happening at 3 seconds. Okay, let's see why that's important. The reason why that's important is because over here, let's look at the first time the diver is at 18. I'm going to go down to see what time that is. Trying to make my line straight. Okay, I've gone down. I know it's not so straight, but it's hard to film and draw straight at the same time. I can see that this is a little bit before 1 second, so maybe 0.8 seconds. Now, what's important for you to understand is that, okay, I've drawn another line down from the other time the diver was at 18. What's important about symmetry is that you understand that this distance and this distance needs to be the same. So between 3 and 0.8, there is 1.2 seconds. That means the next time the diver will be at 18 is 1.2 seconds after 3 seconds, which is going to be, oh, Miss Langrage, I made a mistake, 2.2 seconds. 0.8 to 3 is 2.2 seconds. So over here, we need another 2.2 seconds. And that means this should be 5.2 seconds. The 2 times the diver is at 18. The first time is at 0.8. The second time is at 5.2. And those are symmetric around the middle. 2.2 forward of the middle and 2.2 back of the middle. That is really important. Okay, how long is the diver above 22 feet? So let's look for 22 feet. 22 is the middle of 20 and 24. So my question is, how much time is up here? How much time is happening between the first time the diver's at 22 and the second time the diver's at 22? Well, I'm pretty sure that if I draw a vertical line down, this is going to be at 2 seconds. And this over here is going to be at 4 seconds. So I'm going from 2 to 3 to 4. This right here is a total of 2 seconds above 22 feet. Okay. Okay, here we go. We're going to use symmetry again. Where would the second x-intercept be? Don't forget, x-intercept means when it's on the ground. So here's my diver. My diver goes up. My diver comes down and hits the ground, or in this case, the pool, at 8 seconds. 8, 0 is the x-intercept. I need to order some different color Sharpies on Amazon so I can make this clear. But remember, symmetry, the middle is at 3. To get from 3 to 8, 3 plus 5 gives you 8. So one x-intercept is 5 in front of the middle, and the other x-intercept is 5 behind the middle. So 3 minus 5, that would give me minus 2. Now we could check with our bunny hops too to make sure that makes sense. Here we go. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The other x-intercept would be at minus 2, 0. Okay, last question. Now this is tough. This is for a bonus. If you watched my videos from yesterday, you know that I can write the equation of this with some brackets with an x here and an x here. And remember that whatever the x-intercepts are, the opposites are in the bracket. So since this is a plus 8, over here it's going to be minus 8. Since this is a minus 2, over here it's going to be plus 2. And the other pattern you would have realized and seen, and other rule you would have seen if you did yesterday's work, is that in the front there will have to be a negative since it is opening down. Now, there's actually one more thing that we'd have to learn to make this equation perfect, but we'll learn that another day. Right now, having the minus at the front and the opposites of the x-intercepts inside the bracket is perfect. I hope this video is helpful. If you have any questions about what we've done today, please send me an email and I will help you some more. Bye.